So now that you know a little bit about the common fork join pool, let's talk about the ManagedBlocker interface, which is the mechanism by which the common fork join pool can be expanded and ultimately later contracted. And we'll see how this interface is used to avoid starvation and help improve performance, especially for blocking operations. So if you read the documentation on fork join pool, it says it really wants to be used for compute-bound tasks that run to completion without blocking. And it works quite well for that. Lots of examples of that. However, there are situations where you need to be able to create more threads than you start out with in order to be able to ensure liveness and responsiveness for blocking operations. So keep in mind that if you just have compute-bound operations, they don't block, they just run until they're finished. And therefore, in that environment, it makes sense to have the same number of threads in the worker pool as there are cores. But when you start blocking, you may need more threads than there are cores. And so the ManagedBlocker allows the framework, the ForkJoin framework, the common ForkJoin framework, to automatically and temporarily increase its size. And as I mentioned before, ForkJoin pool is smart enough to know how to reclaim these threads, so if they're not used for a long period of time, it shrinks them back down again, like the Grim Reaper. And therefore, during periods of bursty activity, you'll have more threads, and then when you go back to a more quiescent state, the threads will go away. It also tries to ensure that whatever the target level of parallelism that you've set is met. So it'll increase the threads, but it'll try to increase them and then bring them back down to where they need to be later. The ManagedBlocker interface itself is really simple. There's only two methods that are defined on it. And the first method is called IsReleasable, and it returns true if there's no need to block. So if you have some kind of resource that you can get, say, by trying a non-blocking operation, and it succeeds, then IsReleasable will return true, and it says, we got whatever we needed, no need to increase any more threads, there was no blocking at all. The second method is called block, and typically the way this works is if IsReleasable comes back and says, nope, sorry, I couldn't get it with a non-blocking operation, then the blocking method will be called. And that's an indication to the framework that, oh, we actually are going to have to block. It returns true if no additional blocking is necessary. But that's not typically the case. So let's take a quick look and see how this stuff gets implemented. And then next time we'll come back and see how it gets applied as an end user. So this is how the ForkJoin pool itself will implement these behaviors using the ManagedBlocker interface. So as you can see, here's the ForkJoin pool class. It's got this ManagedBlock method, and it's passed a ManagedBlocker. And this ManagedBlock method will conditionally activate a spare thread, another thread, a new thread, to ensure that there's enough parallelism to keep things making forward progress if one of the threads that is calling will block, or if the calling thread will block. And it does that by this internal call known as try compensate. Try compensate, as the name suggests, tries to compensate for a blocking thread by automatically spawning another thread in the background to take over while this thread blocks. And you can see what it does is it goes into this loop and it checks to see if it's releasable, and if it's not releasable, it then goes ahead and tries to block. And this is the call that might potentially block the calling thread. But that's okay, because up here we called try compensate, and that will go ahead and spawn a thread in case we happen to block. So this is how things work under the hood in the framework. You don't actually have to know or really care how this is implemented, but the behavior of the ManagedBlock method is to use this framework mechanism in order to be able to expand the threads so that there's more that could be added if a given operation will block. Okay, so that's the end of the overview of ManagedBlocker. Next time we'll talk about how to use this interface to write interesting programs.